We can also study metals by looking at their chemical properties. Some metals willingly combine with other elements to form new compounds, while others will not react at all. This is because some metals are more reactive than others, and we can place them in order of how vigorously they react. This order is called the reactivity series. We're now going to look at several different metals and see what happens first when we burn them in air, then when we put them in water, and then finally in dilute acid. Let's start with burning in air and see what happens to the metals magnesium, iron and copper. First of all, magnesium. As we can see, magnesium burns very brightly in air. It readily combines with oxygen to form the compound magnesium oxide. The iron in the form of iron wool burns less brightly. And with the metal copper, there is no reaction at all. We can write word equations for them. Magnesium and oxygen makes magnesium oxide. And iron and oxygen makes iron oxide. So, with burning, magnesium is the most reactive. Then comes iron, and finally, the least reactive metal is copper. Metals at the top of the list are the most reactive, and the metals at the bottom of the list are the least reactive. Let's look at another set of reactions. This time, the metal elements potassium, magnesium, and lead, and see how they react with water. The metal potassium is so reactive it has to be kept under oil and handled very carefully. The reaction with water is very vigorous, producing hydrogen gas and a lot of heat and light. Let's now try magnesium. The reaction is far less dramatic. The tiny bubbles along the metal strip are bubbles of hydrogen gas, so this metal is also reacting with water. And finally, lead, where there is no reaction with cold water at all. The general word equation for a metal reacting with water is the metal plus water equals metal hydroxide plus hydrogen. So for potassium reacting with water, the equation looks like this. Potassium plus water equals potassium hydroxide plus hydrogen. Why not stop the tape and try and write out the word equation for magnesium, as this is very good practice for test questions. So if we go back to our reactivity series, we can put potassium near the top, above magnesium, and lead appears near the bottom. Now the metals always have the same place in this order, so this means we can make predictions about how different metals are going to react. So what will happen if we add them to dilute acid? Well, we can't use potassium or sodium at the top of the table, as the reactions would be explosive. So let's try magnesium, which is below potassium, then zinc, and then copper. And according to this list, copper should have the slowest reaction. Dilute hydrochloric acid is added to the metal magnesium, and straight away the reaction fizzes, letting off bubbles of hydrogen gas which can be tested using a lighted splint.
Ready?
Now let's try zinc.
Okay.
Powdered zinc is used, and again with dilute hydrochloric acid, the reaction is far less vigorous, but hydrogen gas can still be tested for.
Let's do the copper now.
Shavings of copper are used, and this time, when the acid is added, there is no reaction. So the order going from the most reactive is magnesium, then zinc, and finally copper. And we can also write word equations for these reactions. When metals react with acids, the pattern follows: metal plus acid makes metal salt plus hydrogen. So, for example, with magnesium, the word equation is magnesium plus hydrochloric acid makes magnesium hydroxide the metal salt plus hydrogen. So the key points are that different metals react with oxygen in the air, water, and dilute acids at different rates, and that the reactivity series is a list of metals in order of reactivity. Metals at the top of the list are the most reactive, and metals at the bottom least reactive.